Assalamualaikum and good day everyone. My name is Nura Ayuni and today I will be presenting the summary of Chapter 2, which are Vector Analysis and Coordinate System, followed by Chapter 3, Static Electric Field for PHY568 under the guidance of Sir Muhammad Faris. First, let's look at the difference between scalar and vector quantities. Scalar has only magnitude while vector has both magnitude and direction. Examples for scalars are mass, time and energy, while vectors are force, electric field, and velocity. There are three basic vector operations. The first one is magnitude. Magnitude tells us the length of the vector. And then the dot product tells us the scalar value and is used to find projection of one vector into another. While the cross product gives us the vector that is perpendicular to the original of the two vectors. There are three coordinate systems: Cartesian, cylindrical, and spherical. Cartesian uses x, y, and z. Cylindrical uses rho phi z, and spherical uses r theta phi. And we choose the coordinate system based on the shape of the problem, and they can be converted from one system to another. Vector calculus includes four important operations. Gradient shows the direction of the greatest increase. Divergence measures how much the field spreads out. And curl measure the rotation of a field, while Laplacian are commonly used to solve electromagnetic problems. In summary, Chapter 2 introduced vector, coordinate system, vector operation, and vector calculus. These concepts are the foundation of studying electromagnetics. Next, I will be presenting Chapter 3, Static Electric Field. This chapter explains how electric charges create electric fields and introduce the basic concept used in electrostatics. The first one is Coulomb's law. Coulomb's law explains the force between two charges. Like charges repel each other while opposite charges attract each other. And the force between the two charges will become weaker when the distance of the two charges is increased. The next one is electric field intensity or E. Electric field intensity is a force acting on a unit positive charge, and it is a vector quantities because it has both magnitude and direction. And the electric field always points from a positive charge to a negative charge. And the next one, we have Gauss law. Gauss law states that the total electric flux through a closed surface is equal to the total of enclosed charge. And Gauss law, also known as the first Maxwell equation, and it is easier to calculate the electric fields for symmetrical objects such as spheres and cylinders. And we also have electric potential or V, and electric potential is the amount of electrical energy per unit charge, and it tells us how much work is needed to move a charge from one point to another, and the unit is volt. And then we have current density or J, and it is the amount of electric current flowing through a unit area. And it is measured in A per meter squared, and it also helps describe how electric current is distributed inside a conductor. And last but not least, we have electric flux density or represented by D. And it describes the amount of electric flux passing through a unit area. And electric flux is related to the electric field by the equation D equals to Epsilon times E, where the epsilon is the permittivity of the medium. And this concept is important because it is used in the Gauss law. So in summary, chapter 3 explains Coulomb's law, Gauss law, electric field intensity, electric flux density, electric potential, and current density. And these concepts are the foundation for understanding static electric field and their application in electromagnetics. Before I end my presentation, I would like to highlight the relationship between Chapter 2 and Chapter 3. Chapter 2 focuses on the mathematical tools needed in electromagnetics, while Chapter 3 shows how these tools are applied to analyze static electric fields. Together, these chapters help us understand both the theory and its practical application in electromagnetics. And that concludes my presentation. Thank you for your attention. I sincerely apologize for any mistakes or any shortcomings. and all the goods come from Allah Subhanahu wa Taala, and any mistakes comes entirely from my own. And that's all from me. Thank you. Assalamualaikum.